Okay, today's topic is coterminal angles. Now, we talked a couple times about trigonometric angles in standard position, which have an initial side and a terminal side. And let's say we have an angle here, theta 60 degrees. Well, there are infinitely many angles that have that terminal side. Here's one, and that would be, we'll call this one alpha, using Greek letters as tradition with angles. That would be negative 300 degrees. Now these angles both terminate on right at that spot, but they have different angle measurements. They're called coterminal angles. Here's another example. Let's say that we have this angle. Let's put this one right here at 330 degrees. Well, if I go around twice, it's kind of hard to draw this, but okay, there's another angle, alpha. Well, that's 330 plus 360 degrees, so that would be 690 degrees. Those are coterminal angles. All right, well, our work today, if you look in the book, the directions for numbers 57 to 70 say, find a positive angle less than 360 degrees or 2 pi radians that is coterminal with the given angle. All right, first problem, number 57. Given an angle, 395 degrees. Okay, where's 395 degrees? Well, that's all the way around 360 degrees, plus another 35 degrees. So here's what I want you to do. We're going to say theta is equal to 395 degrees. And I want you to draw these angles in standard position, and then draw the coterminal angle. We can write it a couple different ways. I called them alpha up here, but we can also call it theta sub c, coterminal, when that will be 35 degrees. All right, and there's your answer. Okay, let's do another. Number 59. This time it says theta is equal to negative 150 degrees. Oops. Well, that means we're going this way. 150 degrees is over in this territory. Negative 150 degrees. Well, here's our coterminal angle between 0 and 360. Well, that one happens to be 210 degrees. Now, how do I know that? Well, I've seen it before, but how can you figure this out? Well, it's a little bit of intuition will get you there, but we'll use Grapher for this type of stuff. And all you really have to do is you take negative 150 and just keep adding 360 to it until you get a positive number between 0 and 360. Now, if you have to add 360 more than once, you add 360 more than once, and we'll see an example of that here in a second. Let's go to number 61, and we will see an example right here in number 61. Okay, theta is equal to negative 765 degrees. Okay, first thing is, well, how do you figure out where this is, negative 765 degrees? We can count by 360s. You know, this is negative, so we'll go this way. Negative 360, negative 720. All right, so we still need to go another 45 degrees. Okay, so it's going to be down in this area. And this is how I want you to write it. You don't have to spiral around here multiple times, but we know that we are going to go around twice. We're only going to show once. We're going to say theta is equal to negative 765 degrees with 2 revolutions. All right, now the coterminal angle. Again, what we're going to do is take negative 765 and then add 360. That's not between 0 and 360. Then add 360. That is not between 0 and 360. Then we're going to add 360. That is between 0 and 360. So the coterminal angle we're interested in is 315 degrees. All right, there it is. Theta sub c is equal to 315 degrees. Okay, well, these things, of course, can work with radians. And I guess I didn't do an example in this way, but if you had a positive, the 395, I didn't show subtracting 360 off of there, but that's what you would do, is subtract 360 until you get to the proper amount between 0 and 360. Just keep subtracting off 360 until you get there. Now, you can actually do that before you start drawing it in standard position. All right, let's move on to number 63, and the theta value here is 19 pi over 6. Okay, now how are we going to graph that? I like to do what we call count by sixes, because that's the denominator of the fraction. Now, every 6 over 6 is 1 pi. So if I count 6, 12, 18, that's 3 pi. 18 pi over 6 is equivalent to 3 pi. Again, 6, 12, 18. Well, I need one more sixth of a pi. Since 3/6 is halfway between here and here, the angle is somewhere down in there. Okay, there's the angle. 19 pi over 6. Now, radians actually are kind of easy to figure out the coterminal angles if you're comfortable in counting by sixes, or depending on whatever the number's on the bottom of that fraction, that's what you're going to count by. And we'll have other examples. Well, here's the coterminal angle that we're interested in. And it's a little bit more than 1 pi. Well, since we're counting by sixes, remember, when we got to 18, we had to go one more sixth. So that would be 6 plus 1, or 7 pi over 6. That is the coterminal angle. Now, some of you aren't going to like this, and I know that from past experience. So another way to do this is to convert this angle. And I know that a number of you will rather convert this into degrees, find the coterminal angle, and then convert it back. I have no problem with that. Okay, so I'll show you how to do that. Okay, so I can take 19 pi over 6 and multiply that by the conversion factor. Remember, the pi goes on the bottom and the 180 goes on the top. Well, the calculation is, and the pi is reduced, of course, 19 times 180 divided by 6. All right, that's 570 degrees. Well, 570 degrees is, and I haven't done this yet either, but if I divide 570 by 360, that tells me that that's 1.58 revolutions. I want to get to the revolutions between 0, well, put a 0 right there, so all I have to do is subtract the 1 off of that, and now that's 0.58 revolutions. If I multiply that by 360, that tells me the degrees. All right, so the coterminal is 210 degrees. Now all I have to do is reconvert that 210 degrees. This time I put the pi up top and the 180 on the bottom. Now we're going to leave the pi out of this, and I'm just going to have 210 divided by 180, and then convert that back into a fraction. And there you go. 7/6, but remember, the pi is going to be part of that. Well, that's a lot of work to get that answer that we got by counting by sixes, but if you like this better, it's perfectly acceptable. I'm not going to complain about that. Okay, number 65. (23 pi over 5). Okay, we are going to count by fives, because that's the bottom of the fraction. Okay, 5, 10, 15, 20. Now I'm not going to get to 25, but 3/5 is more than halfway between here and here, so we're going to put the side right there. Okay, and there's our 23 pi over 5. Now that was 2 revolutions as we went around. I don't know if you remember that. All right, our coterminal angle. Remember, when we came up on this at 20, we had to go 3 more, so the coterminal angle is nothing more than 3 pi over 5. Again, if you wanted to do it by converting into degrees and then converting back, that's fine. I think it's more work, but you can do it if you'd like. Okay, let's move to number 69. I'm not going to do them all. Actually, let's do 67, because that's an interesting case. We will do them all, I suppose. Okay, number 67 is negative pi over 50. Now, where is negative pi over 50? It's not very much. 1/50th. That's negative 1 pi, so it's down in here. Okay, so that's theta is equal to negative pi over 50. Well, to get an angle between 0 and 2 pi, we're going to have to count by 50ths. Okay? That's 50 pi over 50. That's 100 pi over 50. Well, we're 1/50th short. So the answer for the coterminal angle is 99 pi over 50. Again, 50, 100, 1/50th short. 99 pi over 50. All right, last one. Theta is equal to negative 31 pi over 7. Okay, we're going to count by sevens going this way. 7, 14, 21, 28, that's 2 revolutions, and then we need 3 sevens. Now 3/7 is less than a half, so that's going to be down in this area. This is the way we're going to write it. Theta is equal to negative 31 pi over 7. Okay, now here's another way we can do this by calculator without converting. Okay, I'm going to take negative 31/7 as a fraction, and I'm just sort of going to ignore the pi, because we'll put the pi back on at the end. So what I'm really going to do here is add 2 pi, but I'm not going to add 2 pi on the calculator. I'm just going to add 2. All right, I'm going to add 2. It's sort of like adding 2 pi, because I'm going to put the pi back on in the end. Okay, so that is not between 0 and 2. Add 2 again. That's not between 0 and 2. Add 2 again. That is between 0 and 2. Turn it into a fraction. 11/7. That is the coterminal angle. It's not really the coterminal angle, though. The coterminal angle is 11 pi over 7. We just tack the pi back onto the end of it. And that's all there is to it. So there's a couple ways to find these coterminal angles in radians. I've shown you a couple of them, and you can feel free to use any method you want. Now, I really don't care, but if I'm going to try to come up with some way that you can send me questions and I'll be able to answer them. I'm thinking about conducting some sort of Zoom session, and I think we can do that, but I'll have to get back to you guys on how we're going to do that. All right, now you have some homework that's out of the book just like that, and you also have some homework out of the book, and I have to move the book over here to show you how this is going to work. All right, now the directions are for this section down here. It says, use the circle shown here and find two angles in radians between negative 2 pi and positive 2 pi for any of these points. Okay, now we're going to assume that these points are the points that have come in multiples of 30, 45, and 60 degrees. And I'll tell you what, this video is getting a little bit long, so I'm not gonna do that. We'll hold off on this one because I'm not supposed to. I'm not supposed to do these things too long every day, so we'll hold off on that, and we'll do that at another time. So we'll just go with, and I'm sure nobody's going to get choked up over this, that the homework will be numbers 58 to 70 out of section 5-1. Just the evens, because we did all the odds anyhow. All right. Until next time, see ya.